Welcome everyone to our algebra series, the SSCE aspect of it. Today we'll be starting up with an expansion of algebraic terms. The term expansion in algebraic mathematics is same as in arithmetic. It simply means opening up of barriers or brackets. Let's take for instance the expression t plus s bracket open and close into another bracket open v plus w. It simply means t plus s bracket open and close times v plus w bracket open and close, and it can be expanded as t plus s bracket open and close into another bracket open v plus w bracket open and close equals to, we take t first, spread it over v plus w, so we take t into bracket open v plus w bracket close plus s into v plus w bracket open and close, and the result will be tv plus tw plus sv plus sw. On the other hand, we can expand it as t plus s bracket open and close into another bracket open v plus w. Then we take it t plus s, that will be plus w into t plus s. And when we open it up, we have tv plus sv plus tw plus sw. That gives us the same result. Now let's take another example properly. Expand 2x into bracket open x minus y bracket close minus 3y into bracket open 4s plus 3y bracket close. The options are given. Solution. We write out our problem properly, which is 2s into x minus y bracket open and close minus 3y into 4s plus 3y bracket open and close will be equals to 2x squared minus 2xy minus 12xy minus 9y squared. We have just used the items outside the bracket, each of them to multiply into the items in the bracket, and that is our result. Here we just simplify further. We have 2x squared minus 14xy minus 9y squared. The result is that minus 2xy minus 12xy is what gave us minus 14xy, and that is how far we are expected to go. Let's take another example. Expand the expression 3a minus xy bracket open and close into another bracket open 3a plus xy bracket open and close. The options are given. Solution. We write out our given problem, which is 3a minus xy bracket open and close into another bracket 3a plus xy bracket open and close will be equals to 3a into bracket open 3a plus xy bracket close minus xy into bracket open 3a plus xy. What we have just done, we use the first bracket to spread it over the second bracket, and when we open up our bracket, we now have 9a squared plus 3axy minus 3axy minus s squared y squared, and our result will be equals to 9a squared minus s squared y squared. The two items at the center, 3 plus 3axy minus 3axy, we cancel out. That is how far we are expected to go in this problem. Another example. If x squared minus 5x plus c is equals to bracket open x minus 8 bracket close into another bracket open x plus 3 bracket close, find the value of c. The options are given. Solution. This is an indirect expansion problem. So first of all, we write out our problem, which is x squared minus 5x plus c equals to bracket open x minus 8 bracket close into another bracket x plus 3 bracket close. Expanding the right hand side, we now have our result will be equals to x into x plus 3 bracket open and close minus 8 into bracket open x plus 3. That will give us, when we now open up the bracket, we have x squared plus 3x minus 8x minus 24. Now we can equate both terms. We have x squared minus, that's right hand side, left hand side equals to right hand side. So we have x squared minus 5s plus c will be equals to s squared minus 5x minus 24. From here, we can deduce that c is equals to minus 24. Thus, c is equals to minus 24. We we have compared right hand side, left hand side equals to right hand side. We've compared the items, and hence we're able to deduce our result. Another example: if m plus 1 and m minus 3 are factors of m squared minus km plus c, find the values of k and c. Solution: if m plus 1 and m minus 3 are factors of m squared minus km plus c, then we can equate m plus 1 bracket open and close into another bracket open m minus 3 bracket close is equals to m squared minus km plus c. Expanding the left hand side, we have m into m minus 3 bracket close plus 1 into m minus 3 bracket close open and close will be equals to m squared minus km plus c. And when we open up our bracket, we have m squared minus 3m plus m minus 3 will be equals to m squared minus km plus c. Simplify further, we have m squared minus 2m minus 3 will be equals to m squared minus km plus c. Thus, minus 3, comparing of term, when we compare left hand side to the right hand side, we can say that minus 3 is equals to c and minus 2m is equals to minus km. From there, we can deduce that 2 is equals to k. Next, we take another subtopic, coefficient of term in expansion. This is a subtopic under expansion. Let's take example. Find the coefficient of w in the expansion of 8w plus 3 bracket open and close into another bracket open 8w minus 3. Solution: 8w plus 3 bracket open and close into another bracket open 8w minus 3 will be equals to, we are now expanding, be equals to 8w into 8w minus 3 bracket open and close plus 3 into bracket open 8w minus 3 bracket close. And when we open up the bracket, we have 64w squared minus 24w plus 24w minus 9. And the result will be 64w squared minus 9. From our result, the coefficient of w is 0. Another example. Find the coefficient of xy in the expansion 2x minus y plus 4 bracket open and close into another bracket open 5x plus 3y bracket close. Solution: using the smaller bracket of two terms to multiply, we will have bracket open 2x minus y plus 4 bracket close into another bracket open 5x plus 3y bracket close will be equals to 5x into 2x minus y plus 4 bracket close plus 3y into 2x minus y plus 4 bracket close. And when we open up our bracket, we have 10x squared minus 5xy plus 20x plus 6xy minus 3y squared plus 12y. Next, we collect like terms together, and the result will be 10x squared minus 5xy plus 6xy plus 20x plus 12y minus 3y squared. And when we simplify, we have 10x squared plus xy plus 20x plus 12y minus 3y squared. From here, we now get our result that the coefficient of sy is plus 1. Another example. What is the coefficient of s in the expansion 2s minus 3 bracket open and close into another bracket open 3s plus 8 bracket close? The options are given. Solution: first, we expand as 2x minus 3 bracket open and close into 3s plus 8 bracket open and close will be equals to 3x into bracket open 2s minus 3 bracket close plus 8 into bracket open 2s minus 3 bracket close. And the result will be 6x squared minus 9x plus 16x minus 24. Simplify further, we have 6x squared plus 7x minus 24. Thus, the coefficient of x is 7. Another example. Find the coefficient of m in the expansion of m divided by 2 minus 1 over 1 over 2, bracket open and close, into another bracket open, m plus 2 divided by 3, bracket close. The options are given. Solution. First, we write out our problem. M divided by 2 minus 1 over 1 over 2, bracket open and close, into another bracket open, m plus 2 divided by 3, bracket close, will be equals to, we change the mixed number into improper fraction. In the first bracket, we now have m divided by 2 minus 3 divided by 2, bracket close, into another bracket open, the second bracket, which is m plus 2 divided by 3 bracket close. Next, we can now split out one of the bracket over the other one. The one that has plus will be easier to multiply against the one that have minus. And then we have m into bracket open, m divided by 2 minus 3 divided by 2 bracket close, plus 2 divided by 3 into bracket open, m divided by 2 minus 3 over 2 bracket close. When we open up the bracket, the result will be m squared divided by 2 minus 3 divided by 2m plus m divided by 3 minus 1. What just happened there in the second bracket? Once the 2 divided by 3 multiply the first item, 2 will cancel out. Similarly, when you multiply the second item, 2 will cancel out. Hence, we have that result. In the second case, the 2 will cancel out with the 2, 2 in the numerator will cancel out with the 2 in the denominator, and 3 will cancel out with the 3 in the numerator and denominator will cancel out there. And that's why you have the result of 1. So, we try to work on the items that have m so that we can do simple LCM there of fractions. So we have the LCM of 2 and 3 is 6. So when 2 go into 6 is 3, and 3 times 3 will be giving you 9. That's why you have minus 9m. And when 3 go in, divide 6 will give you 2. That's why you now have 2 times m, which will give you 2m, divided by 6, the LCM. And you now close the bracket minus the 1. And the result will be m squared divided by 2 minus 7 over 6m minus 1. Thus, we can confidently say that the coefficient of m is minus 7 over 6, which is the same as minus 1 whole number 1 over 6. We've come to the end of the examples under this subtopic. Next, we have some exercises which I will advise strongly. Try your hands on them while we quickly move to the next subtopic, factorization. The term factorization is the reverse of expansion, the subtopic preceding this. The process of factorization involves factoring out a common factor from a given expression. This is done based on the given problem. Different strokes for different folks. Some of the methods are shown below. One term factor. When confronted with factorization problems of the forms shown below, it is helpful if we factor out a letter or term common to both sides. Examples. A, we have ax plus ay. We just factor out the a, which is will give us equals to a into x plus y. B, if we have at squared minus a squared t, we look for the common factor here, which will be at. So we'll bring it out. At into bracket open t minus a bracket close. Let's take another example. C, xy square z cube minus x square y z square. The common factor here will be equals to xyz square. When you look at it, this is z square is common to both items there. And when you open up the bracket, you'll be left with yz minus x. Let's take D. If we have s into t minus 1, bracket close, plus 3 into 1 minus t, bracket close, will be equals to s into t minus 1. In the first case, you have no problem. But in the second case, we just factor out the minus so that our t minus 1 will be the same in both cases. So you now have minus 3 into t minus 1. You can now see that we have t minus 1 common to both. So we can now proceed to say, okay, t minus 1 factored out, and you'll be left with s minus 3. Let's take example to buttress our point. Factorize the expression am plus bn minus an minus bm. The options are given. Solution. Grouping like terms together, we now have am plus bn minus an minus bm will be equals to, that's our given problem, be equals to. We are now grouping like terms together. We have, at the right hand side now, we now have am minus bm, the one that have m together, then plus bn minus an. We brought the m together, we brought the n together, which will be equals to m into a minus b, bracket open and close, plus n into b minus a, bracket close. We will not get the desired result, so we factor minus n instead of plus n. And that will give us equals to m into bracket open a minus b, bracket close, minus n into bracket open minus b plus a, bracket close. Is same as m into bracket open a minus b bracket close minus n into a minus b bracket close. Now we can now factor out m minus n, and then we'll now be left with also a minus b, two bracket open and close multiplying each other. And that's our desired result. Next, we take another example. Factorize x minus ay plus y minus as. The options are given. Solution. Grouping like terms together, we have that our given problem, x minus ay plus y minus as will be equals to minus as minus ay plus y. We have just grouped x items together and the y items together. And when we factor out x, in the first case, we have x into bracket open 1 minus a bracket close minus y into a minus 1. We will not get the desired result, so we factor plus y instead of minus y, and that will give us x into bracket open 1 minus a bracket close plus y into minus a plus 1 bracket close, which is the same as x into 1 minus a bracket close plus y into 1 minus a. We can now factor out s plus y and bracket open and close into 1 minus a bracket close. We've gotten our desired result. Another example. Factorize 3xg minus hy plus 3hg minus xy. The options are given. Solution. Grouping like terms together, we have that our given problem, which is 3xg minus hy plus 3hg minus sy will be equals to 3xg plus 3hg minus hy minus xy. We've just grouped the terms that have like terms, the g together and the y together. Now, factorizing g out of the first item, 3 and g out, we have 3g will be into bracket open s plus h minus y into h plus x, and that is the same as 3g into bracket open s plus h minus y into s plus h. Is the same. When you say 2 plus 3 is the same thing as 3 plus 2. So we can factor out 3g minus y, open bracket and close it, then we'll now be left with x plus h, and that's our desired result. Another example. If x minus a bracket open and close is a factor of bx minus as plus s squared minus ab, find the other factor. The options are given. Solution. Grouping like terms together, a given problem which is bx minus as plus s squared minus ab will become s squared minus as minus ab plus bs. And when we factor out x, we have, in the first case, we have x into bracket open x minus a bracket close minus b into bracket open a minus s bracket close. This step cannot help us, so we retrace our step as equals to x into bracket open x minus a plus b into bracket open minus a plus x bracket close. It's same as x into bracket open x minus a plus b into x minus a. And we can now factor out x minus a, open and close bracket, and you will be left with x plus b bracket close. Thus, the other factor is x plus b. Already we have been told that we have x minus a as one of the factors. So the other factor is s plus b. Another example. Factorize 5xy plus 90qy minus 30y squared minus 15s cubed. The options are given. Solution. Grouping like terms together, our given problem, which is 5xy plus 90qy minus 30y squared minus 15s cubed, will be equals to 90qy minus 30y squared plus 5xy minus 15s cubed. And we can simply factor out from the first item 30y, and that will give us into bracket open 3q minus y bracket close plus, when we factor out 5x in the second group of items, we have y minus 3q bracket close. Our purpose is not served in this step. We're taking this step, but we have equals to 30y into bracket open 3q minus y bracket close. The first item is not actually the problem, it's the second item, because we want the two brackets to have the same item. So we have minus 5x by factoring out minus 5s, they will be left with minus y plus 3q, bracket open and close, which is the same as 30y into 3q minus y, bracket close, minus 5s into 3q minus y, bracket close. Now we have achieved the same item in both brackets. So we can factor 30y minus 5x out, and you'll be left with 3q minus y, bracket open and close. The first bracket can be factorized further as we factor out 5 and we have 6y minus x, bracket open and close, 3q minus y. And that gives us our final result. We've come to the end of the examples under this subtopic. Next, we have some exercises which are taken from page 34 of the hidden fact in new SSCE mathematics. I advise you try your hands on the exercises. The answers are given at the answer section of the textbook, either the hard copy or the soft copy. Thank you.